Welcome to basic differentiation. So the reason we differentiate is it finds the gradient of a tangent to a curve at a particular point. And we will use this understanding to apply on many occasions with other videos. So for this video, we're going to look at just how we do basic differentiation. So if we're given a function, x to the power of n, then to differentiate f dash of x, which represents differentiation, we bring the power down the front, so the n comes down the front, and we lower the power by 1. So our power becomes n minus 1. So let's put that in place with some basic rules or basic functions that we've seen before. So we'll start with f of x equals x squared. So if f of x equals x squared, and we use our rule, bring the power down the front, lower your power by 1, that means that f dash of x becomes 2x to the 1. So we lowered the power by 1. And we don't need the power of 1, we can just write that as 2x. The second one was x cubed plus 3x minus 5. So let's, for this first time, let's put the power of the x as a 1, and the 5 doesn't have an x, or it can be x to the 0 after it, just so that we understand what happens to that constant term at the end. So for the x cubed, we bring the power down the front, which is the 3, and we lower the power by 1, so we get 3x squared. For the 3x, we bring the 1 down the front, and 1 times 3 is 3, and we lower our power by 1, which becomes x to the 0. With the 5 on the end, if x had a power of 0, we'd bring that 0 down the front, and 0 times anything just becomes 0. So anytime we see a constant or a number by itself, we are going to, when we differentiate it, it will always turn to 0. So making this simple, or simplifying this, f dash of x now equals to 3x squared plus 3. So now to differentiate 5x to the 8 minus 4x squared plus 3. So 5x to the 8, you bring the power down the front, so you bring the 8 down the front, 8 5s are 40, lower the 8 by 1 becomes 7. 4x squared, bring the 2 down the front, 2 4s are 8, lower the 2 by 1, and we just write it as 8x. And the 3, a reminder, if there's a number by itself or a constant, it differentiates to 0, so it disappears. So f dash of x is 40x to the 7 minus 8x. And for the final one, if we can expand brackets, then we will do so, and it's easier to differentiate that way. But later, when we have brackets that have high powers, and it takes a lot longer to expand brackets, we will learn another method to differentiate those. So for this one, we're going to expand the bracket, and we know that when we expand x plus 4 outside of x plus 5, we get x squared plus 9x plus 20. Now we differentiate. Power down the front, so x squared becomes 2x. The 9x differentiates to 9, and the 20 differentiates to 0. So f dash of x is equal to 2x plus 9. And a shout out to Zenny, who suggested that a shout out should only be done if there was a reason. Thank you.